Assalamualaikum warahmatullahi wabarakatuh. Right now, I want to explain what is the differentiation. Do you guys know what is the meaning of the differentiation? The differentiation is a mathematical method to allow us to find rate of change. Differentiation basically to find the derivative. It's also basically related to a function that we can determine if the function is increasing or decreasing. Do you guys know that the differentiation is very useful in our life? It can be used in variety of situations. The differentiation can find the rates of change, and the differentiation can also determine and calculate something with more accurate. Firstly, the differentiation can find the rates of change. We all know that f prime x is the rate of change for the fx. But for example, for situation in our life is we can find the population of the cats in years. By using the method of differentiation, we can determine whether the population of the cats is increased or decreased. Besides that, we also can know the profit or loss for the business. Secondly, the differentiation can determine and calculate with more accurate. For example, we can check the temperature variation. We all know that the temperature is very important to determine whether someone has a fever or not. During the pandemic session, the person with high temperature not allowed to be in crowded place. The differentiation also can determine the speed or distance such as mile per hour and kilometer per hour. Nowadays, there are many types of vehicle that capable the long distance with different speed. So clearly, the differentiation is very useful in our life.
Hi and Assalamualaikum. So before I show you a basic question of application of differentiation, let's see the formula to find area and volume of basic solid figures. The first one is cube. Area equals to 6x squared, volume equals to x cubed. The second one is cylinder. Area of a cylinder equals to 2 pi r squared plus 2 pi r h. And the volume of a cylinder equals to pi r squared h. Cone. The area of cone equals to pi r squared plus pi r l, and the volume of cone is 1 over 3 pi r squared h. Sphere. Area equals to 4 pi r squared, volume equals to 4 over 3 pi r cubed. Hemisphere. Area equals to 3 pi r squared, volume equals to 2 over 3 pi r cubed. What is related rates? Related rates are rates of change associated with two or more related quantities that are changing over time. For example, a spherical ball is being filled with air. Both radius and volume of the ball are increasing. Arguably, the rate of change in the volume V and is related to the rate of change in the radius r. In this case, dV over dt and dr over dt is related because V is related to r. Now let me show you the basic question of application of differentiation.
The radius of a sphere is increasing at the constant rate of 2. How fast is the volume changing when the surface area is 8 to m? So, given the radius of a sphere, the radius, so it is dr over dt. Okay, and then we need to find the volume, so dv over dt. And the question says when the surface area is 8, when area is 8. So the equation, the volume of sphere is V equals to 4 over 2 pi r cubed. So here we got dV over dr. This this is what given, and this is what we want to find. And this is when criteria is true. So we differentiate the equation, and it will be dv over dr equals to power times power minus. So 4 over 3 times 3 equals to 4 pi r squared. Okay, so we want to find dv over dt. So here is dv and dt over here. The only this they don't have is dr. So this will be dr. And we got dv over dt equals to dv over dr or pi r squared times dr over dt 2. And then we got 8 pi r squared.
Hi, so for now, I would like to share with you guys the second question regarding the topic application of differentiation. So let's look at the question and answer it. A cylindrical can has a radius of r centimeter and height of r plus 4 centimeter. The can is expanding at a constant rate of 5 centimeter cube per second when heated. This means it has a positive rate because it's expanding when heated. How fast is the radius changing at the instant when the radius is 3 centimeter? First and foremost, we need to take out all the information given from the question. So from here, we know that the question asks us if the radius is 3 centimeter. The height is r plus 4 centimeter, and from the constant rate, it shows that the unit is centimeter cube and second, which means centimeter cube is a volume and the second is for time. Thus, the equation is dv over dt equals to 5 centimeter cube per second. For number 2, we need to create an equation to find the answer. And from the question above, it says they need us to find the radius changing. And we need to find the dr over dt, which is the radius changing. Then I will separate the dr and the dt into different fractions. The dr will stay as a numerator and dt will stay as the denominator. If we doesn't know what we need to put here, such as x, we need to refer to the information given or information that we have ticked out. And here I have dv over dt, so I can substitute x as a dv. And we know that this dv over dt is 5 centimeter cube per second. Okay, then we need to find this dr over dv. From the volume, we can know the radius because the radius is inside the volume equation. Thus, I use the volume equation for this. The volume for the cylinder is pi r square h. And from the information, we know that h is r plus 4 centimeter. So I substitute it r plus 4 and v equals to pi r square, pi r cube plus 4 pi r square. Then we need to differentiate v dv over dr. After differentiate it, then we get 3 pi r square plus 8 pi r. Then I'll substitute r as 3. And the answer for dv over dr is 51 pi. Finally, we can include it in the equation that we have made it first. This one. dr over dt. What we have done above, we've got dv over dr. So, in order to get dr over dv, we need to flip it over. Because this is 51 pi over 1. When we got dr over dv, we will get 1 over 51 pi. Substitute the dr over dv and dv over dt from the question. We can get 5 over 51 pi centimeter per second. So, in conclusion, differentiation actually can help us to solve many types of real-world problems as they are met in many engineering and science problems, especially when modeling the behavior of moving objects. In Isaac Newton's day, one of the biggest problems was poor navigation at sea. there was not a good enough understanding of how the Earth, stars, and planets moved with respect to each other. Thus, this differentiation and integration was developed to improve this understanding. That's all from us for this interesting topic. Thank you so much for listening and watching. Thank you.
I know you